All right, hello everybody. My name is Frank DeLise. I'm a director of game solutions at Autodesk. I'm here to talk to you about some new stuff we're working on. Very excited about that. I'm going to try and talk as little as possible and do it all live demonstration of what we're talking about here today. So basically, for those of you who don't know Autodesk is a design and entertainment tools company, creating everything from tools from AutoCAD, the tools that probably design this building, to engineering tools, to a media entertainment division. And over the years, we've built up 3D content creation tools for everything from Max, Maya, acquisitions such as Saltimage and Maya, Motion Builder. So over the years, we've built up extensive 3D knowledge and tools that are mostly used for entertainment and games, or even design visualization. So if you look at some of your favorite movies, like maybe Avengers or Avatar and that sort of stuff, they mostly use tools like Max and Maya and Saltimage to build that content and those animations and that sort of thing. So we have a long history in both film and AAA console game development. And now with this new explosion in indie development, there's a lot of new stuff that people need that we're excited to work with you guys on. So if you look at some of the games, like these are some example games that people have been using Max and Maya for, and Saltimage, so like The Last of Us, and even games like the new Farmville even has 3D elements in it too. So there's a lot of big game companies that have been using these tools. But when you look at indie mobile game growth, it's just been tremendous. It's just nothing compared to the growth of indie games. Typical console titles, maybe there was 2,000 games released over, 10 plus years, right? Now you're talking about 30, 40, 50, 60,000 of these indie mobile games within months or within even one year. It's just tremendous explosion in indie game development. And Unity has really, really helped that explosion in these games. But, a lot of our tools have been designed for these large enterprise companies, everything from, from console developers to film companies. So if you look at our products today, it's really offer, besides the design visualization products, from entertainment purposes, we sell consumer products, which are things like 123D Creature, 123D Catch, Pixlr, pretty awesome tools. For those you don't know, like for example, we have almost 100 million consumer products that are being used out there. There's just crazy amount of users on these tools, but mostly in the consumer market. Like for example, 123D Creature allows you to use an iPad to sculpt a character and then hit the print button and it will send you a model in the mail, or you can export it out as FBX. Pixlr is a free Photoshop-like tool. 123D Catch is a tool that allows you to take pictures of something and it'll turn it into a 3D model. So there's a lot of really cool tools we have in that consumer space. And Sketchbook on iPad, that sort of thing. And on the enterprise side, for film and high-end games, we've got Max and Maya and Mudbox. We've got a lot of great tools. But the prices, we've got stuff from free all the way up to $4,000. There's a big gap in the middle. So we really felt that something was missing here for indie game developers, something that was a little more affordable than that $3,000 content creation tool. Because maybe if you're a game, you really don't need to create crazy hair solutions for a rendering that you're going to do for a high-end movie. So we just all of our tools pretty much had everything in it, everything out of the box into that one tool, and it cost a lot of money. So we felt that there was really a gap here in the middle that where indie developers can get something a little more affordable that has a tool set that works with Unity to create these mobile games. So I'm going to show you just a real quick video. Little sizzle reel to give you an idea of what we're working on. announced at the show Maya LT. So Maya, just so you know, is our most advanced, one of our most advanced 3D DCC tools for film and games. And we decided to take that product and cater it towards indie development, to give you everything you need to do modeling, texturing, animation, all the tools necessary to create indie game content. Which is awesome because now you get a tool that again, is used by tons of artists out there, but at a super affordable price to create indie game content. So, again, some of the tools that are in there, it's full modeling, full texturing, lighting, animation, exports and imports FBX files, works on the PC and Mac platform. Additionally, before I go into a demo, maybe I should go, let me show the price real quick first. We're talking about $50 a month for this product versus almost $3,600 as this product is typically. So this gives it a great price point to try out something, use it as your budget of your game grows, and give you all the tools necessary to create that content. And we sell it in both monthly, quarterly, annually, and even perpetual licenses where you can get it, you can buy it and own it if you want for $7.95. So it's definitely a great tool for this. So instead of talking about it, I'm going to have actually Matt Doyle here. He's going to give you a demonstration of all the things it has, a quick demo showing how to get assets in and out of Unity with some real workflows.
Thank you, Frank. Good afternoon, everyone. Hope you're having a good show here at Unite. I'm going to take you through kind of a whirlwind tour. I talk a little fast, so try to keep up, of what is new in Maya LT, or I should say what is cool in Maya LT, what I like about the tools. And we're going to basically tell a story, and that's the story of going from modeling to texturing to skinning and to animating a character for a real-time game for an engine such as Unity or whatever the case may be. Maya LT has full support for FBX format. So all of this stuff you're about to see today will plug right into Unity, which obviously also supports FBX. All right, so let's go ahead and get started with the demonstration. So you can see here I've got my little guy Sven. I'm going to show you from modeling to texturing to skinning to animation, as I said, all the cool tricks that I know of. How many of you are actually 3D artists? Okay, now how many of you are 2D artists? Okay, so the good news is Maya LT works for 2D artists as well, and I'll get to that later on in the presentation. But first of all, let's take a look in order here of what it would take to go from concept into a full game character that works inside of Unity. Now obviously, my end result, what I want to see, is here inside the Unity game engine demo I've put together, is my character fully shaded, fully lit, running around with the animations I've created nicely, and that's where we want to be, right, as game developers. It's fun to do what we do, but ultimately what we want to do is have a game that we can then ship to customers. Okay, so for the first part of the demonstration, let's talk a little bit about the modeling tools inside of Maya LT. Now, Maya LT has an impressive suite of modeling tools from NURBS to subdivisions to polygon modeling. And so what I'm going to show you today is the modeling toolkit, which is specifically designed for doing polygon modeling, which is the type of stuff that most games use. So the modeling toolkit is extremely powerful with all of the features that you're going to need in one place. So you can see here that with this guy here, I've got a gap in his arm. Simply selecting these edges, I can click Bridge, and now I can shift drag to add more edges. So I'm going to leave him right there. I can also easily do extrudes. So for instance, if I just turned on extrude mode and go into face mode, I can simply start to extrude parts that I want. And shift dragging will allow me to continue an extrude. However, if I were to actually select some faces, we can see here that I can also extrude and then switch quickly to bevel and get a nice beveled effect there. So you can see the power of the tool there. It's very fast. You can very quickly switch between verts and edges and faces or work with them all at the same time in multi-component mode. Now, what I really like, however, about the modeling toolkit is something that game developers have to do all the time. How many of you have ever had to retopologize a mesh for a game? A few of you. So some of you know what this is, some of you may not. Sometimes you're going to have a game asset that is basically a high-res version for, say, a cinematic cutscene or whatever, but you want to create a low-poly cage version of that you can then take into the real-time aspect of your game. Well, this is where the modeling toolkit really shines, and you'd want to pay attention to this part here. So I'm going to select as a constraint this head that I've created, And now that I've selected it as a constraint, anything I do from now on is going to be constrained to the surface of that head. So I'm going to enable Quick Draw now. And inside of Quick Draw, I can very quickly lay down some polygons around his eye and bridge those. I'm going to turn on X-rays so it looks a little better here. I can also drop in verts, just dropping them right on the face, and then shift drag to fill in those polygons. I can also, let me zoom in here a little better. I can also add or move the verts around, adjust them manually with the middle mouse button, as well as edges. So it's a very powerful tool for creating a retopology, you can see there. Now I'm going to go ahead and turn off my constraint, and I'm going to hide this mesh. And so you can see the beginnings of our retopologized version there. Obviously, I need to take it a little bit further to be finished, but you can get the idea of how powerful the modeling tool is for creating this type of retopology. And then obviously, you would take that retopologized version, texture it, put it in your game. All right, so let's go ahead and move on to texturing. Now, Maya LT provides a considerable amount of texturing ability. Just like the full version of Maya, it still has the hypershade. However, it also has the ability to do DirectX 11 viewport support, just like the full version of Maya, as well as a really cool new tool that we're adding in that I'm going to talk about in a second. But first, I want to show you DirectX 11's viewport support. So here I have my Sven. I finished modeling him. You all saw me do it. It was really fast and pretty awesome. But now I want to texture him. So I'm going to select his mesh here and just go ahead and assign an existing DirectX 11 shader that I've put together. Now, on his body here, what we're looking at is we have this shader that we call the DirectX 11 Uber shader, and it has all of the bells and whistles that DirectX 11 supports on the video card. So you have things like dynamic tessellation, emissive, subsurface scattering, image-based lighting. All of that can be done in this single shader. So if I drop down to my image-based lighting, if I turn that off, you can see the difference that makes. Now I can also increase the intensity. I can get rid of the blurring. So now we can see it's a much more metallic surface. Okay? Now I'm also going to jump to the head and show you something even cooler, and that is the subsurface scattering. If I can find my face texture here, there we go. All right, so this shows DirectX 11's advanced subsurface scattering or translucency effect. So if I go back to the material and turn it off, you're going to see what it looks like without that. So this is what the shader would look like without subsurface scattering. Now when I turn on translucency, and I'll show you what the actual texture map looks like, this is just a black and white grayscale image to let you know what areas should be more translucent. Obviously the ears tend to let sunlight through more. And so we can see here that's exactly what's happening. It actually interacts with the lighting, so it makes it look like it's translucent. It's a very cool effect, and there's a lot of other interesting things you can do with DirectX 11, including dynamic tessellation, which I'll get to in a moment. But what I really want to talk to you about today is the new shader effects. So this is going to blow your mind. This is pretty sweet. Have you ever wanted to, well, let me ask, how many of you are tech artists? Not very many, and there's a reason for that, because it's really hard to be a tech artist. How many of you have ever wanted to write your own hardware-based shaders, though? A few of you, okay. So Unity has full support for hardware-based shaders. I'm sure a lot of you that are Unity developers are aware of that. However, writing your own shader is an extremely difficult thing because it's basically writing a C program. However, with shader effects, we now give you an artist-friendly way of creating these hardware-based shaders. That includes HLSL, GLSL, CG, all with an artist-friendly node-based editor. And I'll go ahead and pull that up now. Let's kind of position our guy here. So here's my body texture again. And I'm going to show you just briefly some of the power of this node-based editing tool. So everything you need to create a hardware-based shader is in here. I can see here, if I go to advanced mode, I've got a considerable number of nodes in here, including every math node you could ever want, math, as far as cosine, sine, dot product, cross product, add, subtract, multiply, all of those things you're going to need. Textures, values like floats and bools, as well as matrices for projecting into the world or the camera space, all that stuff is here. All these are things that you would normally have a tech artist write for you. So all you need to do is select those nodes, add them into the scene, and then wire them together to get some really advanced shader effects. So take Sven here, my little guy. He doesn't really have a lot going on besides a diffuse texture. I've pre-baked some stuff ahead of here. I've got this image-based lighting node group here that I've put together. It's actually simpler than it looks. But all I'm going to do for now is I'm just going to pipe the result of that into the surface shader to show you the reflective quality that that adds. Now that's a little harsh. That's not really what I want. So what I can do is I can go to this floating point value I've added to the texture's map level, and I can drop that down to something a little more reasonable. Let's put it at 3. Maybe a little bit more. Let's try 5. So now that's a little better. That's a little more what I want to go for. However, I can go even further than this and make it look more interesting by adding a normal map. I'm sure a lot of you as game developers are familiar with what a normal map is, so let's just go ahead and add that in. And we'll load it in here. Okay, now I'm just going to wire it up to my surface shader. And once I do that, it will add a nice little effect, but still not quite where we want to be. So now I can add the normal map to the image-based lighting as well. And so now my image-based lighting is actually taking into account that normal map. So it gives it a much cooler look. There's more of a texture to it. All right? And now I'm going to go even further. I'm going to really do something cool here, and that's I'm going to add a rim light. So I'm sure a lot of you as game artists are familiar with rim lighting. It's the effect of seeing the backlighting behind a character. So I've set up this rim light ahead of time here and expects a Fresnel node. That's the ability to have a glancing angle so you can see that effect. It needs to know where the camera vector is, and I've got some floating point values for min, max, and strength, a color node, and my lighting vector. And I'm putting in a light list for my lighting vector so it knows where those light rays are coming from. And I'm actually piping in the lights from the Maya scene here. These are my 3 lights, and if I look over here in the drop-down, I can see them. I can set this to auto, or I can specifically tell it what lights to use. In your game engine, it would specifically choose the lights at those indexes, 0, 1, and 2. So now that I've got my shader set up, I'm just going to pipe this in to my ambient color. And so right away, we can see that rim light effect on the character. But I can go even further now and make that even better. What I'm going to do now is pipe in my normal map to my Fresnel. And now even the normals are being affected by rim lighting, which gives it a very nice effect. So there's a lot more I could do here, but you can really see how high quality this shader is and how super cool it looks and how easy it is to build something like this. And you can get even more complex if you want. You can really build some impressive shader graphs. But the coolest thing about this whole thing, this is not just a toy. This is for a production environment. So once you're done building your shader graph, you simply go over here to the final output, and inside the attribute editor, I can actually export this as a CGFX, HLSL, or GLSL file. And then once I've done that, here's my file as if a tech artist actually wrote all of this. And it's highly optimized, so you're not going to have to go in and re-optimize everything. But you can see how much work you would have to do here. This gets you a long way towards getting your own shaders. And then, yes, Unity supports these shaders. There's a little bit of wrapping you're going to have to do to get it in there, but for the most part, everything is done for you ahead. All right, so shader effects, super cool, very exciting. We're just now releasing this inside of Maya LT. All right, so let's move on to another exciting part that I like, and that's texture baking. That's creating displacement maps and normal maps for game characters. Actually, you might want to see me export this, right? You probably want to see this go into Unity, huh? So let's do that first. Let's jump back to my DirectX 11 character here. And let's just go ahead and select all of that. And let's go ahead and export him into Unity. And we'll just drop him right here. We'll call him Sven2. So we'll jump into Unity. Unity will bring him in, and inside my models folder, I should have a Sven2 asset. Sure enough, there he is. I drop him in the scene. Bam. So that's how easy it is to get an asset into Unity from Maya LT. Fully shaded, all the effects that we've applied are there. All right, so let's go ahead and move on now to displacement mapping and normal mapping with Turtle. All right, so this guy's a little different. This is a character I created inside of Mudbox. He's a very high polygon head mesh of 2.4 million polygons. And then I have a low poly cage version next to him of about 9,500 triangles of retopologized version that I've created. So you can see the considerable amount of detail in this guy over here, but I can't put that into a game in real time, right? I've got to reduce him, but I want to keep all that quality. So this is where Turtle, the texture baking solution inside of Maya, is going to come in handy. So all I need to do is select my cage, and I'm going to bring up Turtle here. And Turtle allows me to do a lot of cool stuff, but right now what I want to show you is how to bake a normal and a displacement map. So all I'm going to do is select my source and my target meshes, and then I've got my output set to create a normal map and a displacement map, and then I simply need to render. And so we'll just wait for a few seconds while Maya does its thing. It won't take too long, but the great thing about Turtle is you can do all kinds of maps. You can do normal and displacement, ambient occlusion, light maps, global illumination, with final gathering, so you can get some really high quality light maps for your games. So there's my displacement map. It's a grayscale displacement map. How many of you are familiar with displacement mapping? Okay, so quite a few of you. For those of you that aren't familiar, it's the ability to use a texture to create a detail on a mesh, and it's actually done on the graphics card. The graphics card actually dynamically creates that detail using a texture. And there's my normal map. That's the stuff that's baked into the image based on the lighting around it. Or not baked, but rather the lighting affects the mesh in that way. So now that I've baked my images, I'm going to just assign this DirectX 11 texture. And this DirectX 11 texture is using the displacement map and the normal map, and yet it's still only 9,500 triangles. You can see the cage there. However, it looks a lot better than that, right? Well, see, that's the effect of displacement mapping and of normal mapping. If I were to go into the attribute editor and check out my material for this guy, I could turn on the wireframe mode, and you can see exactly what's going on with displacement mapping. So you can see it's generating these little triangles everywhere, and I can actually reduce or increase that value dynamically. And Unity has a shader inside of it that does this very thing on the fly at runtime. It's a tessellation shader. So very impressive, very cool stuff. All right, so let's go ahead and jump on to rigging and skinning, another important part of game development. Obviously, your characters, if you want to animate them, they have to be rigged. They need a skeleton, and the skeleton needs to be bound to the body. So let's talk about that for a few seconds, or maybe a few minutes. All right. So first of all, we need to create a skeleton. And there's a couple of ways to do that in Maya LT, but one of the best and most common ways is to use the joint tool. So the joint tool basically allows me to just start laying down bones or joints. So if I start here in the arm, let me turn on my X-ray mode here. Let's try that again. Oh, I can't see my joint here. One second. There we go. I see it in the back there. But you notice as I was creating the joints, there we go. It's not actually creating it in the arm. That's kind of a bummer. Now I have to go and move that. However, with the joint tool's new projected centering ability, I can actually turn that on, and then no matter where I draw, let's start with the spine here. I can actually draw my spine where I think it should be based on this view, and now as you rotate around, you can definitely see that it's inside the character's body. So that saves a lot of time. That's something that has been a big problem for a while. Likewise, I can also turn on symmetry. And now as I draw my bones in the arms, we can see it draws it on both sides. So I'm running a little low on time, so I'm going to jump ahead now to human IK. I'm going to go ahead and skip through the skin binding part. But human IK is basically a way to create very quickly a control rig that allows me to do animation using full body inverse kinematics. So we can see here towards this human IK solution I have here that I have created a full control rig for the skeleton. Okay? Now what's cool about this is this control rig, as I move the gun, it's going to move his arms as well. So we can see that. And likewise, if I move this part of his body, it actually animates his knees. So this is all built into Maya LT, allowing you to rather than animating the joints from shoulder to arm to elbow and so forth, you can animate from a goal, and the rest of the body will follow that, and you can create your animations much more quickly that are believable. Okay, so I'm almost done here. Let's wrap up with animation just real quick. And then we can get on to some Q&A. Is that right? A few more minutes, all right. So Maya LT also has the full solution graph editing tools as far as Maya's animation tools go, as well as the dope sheet editor. So I can very quickly come in and select an animation, go into my dope sheet, and using the dope sheet, I can select keyframes, and then I can move them around to a different position. So we can see here that it's affecting the entire animation as I drag that around. The power of this is being able to copy frames and paste them into different spots, drag them around, and then of course the graph editor is going to allow you to go in and manually adjust the interpolation of those keyframes. So we can see all these keyframes here. I can move those around and adjust the interpolation. So a very powerful suite of animation tools. I don't have enough time to go into too much detail, but I'm over at the booth. You guys can always come out there if you want to see more information about this stuff. And of course, finally, when you export this into Unity, you've got your animated character, full mechanism support, as I already showed you, running around in the level, and you're good to go. So I'm basically out of time. I hope you enjoyed the presentation. It's a lot to cover in 20 minutes, whatever it was, 15 minutes. So come by the booth. I'll definitely be happy to show you some more detail. If you really ask me nicely, I might even let you play with it. So I'd just like to thank Dell for letting us use this cool laptop today, and thank Frank, and thank you guys for listening.
So Maya LT is actually available to download today. You can trial it. It's up on the website. You can go up to was it autodesk.com/Maya LT. So you can again you can download it. You can buy it. It's available today. So it's very very cool. I think I got like 2 minutes left. Any questions out there? Yeah.
Can you still do like set-driven keys and stuff?
Yeah, some of the like advanced like spline IK and set-driven keys, those are in Maya, not in LT. Yeah.
Any plans on doing this for Macs?
There's talk about doing it for any of our products. I think that yeah, we're trialing this out basically for indie game development, but yeah, Max is heavily used right now for indie games too. So it's under consideration, of course. Yeah. No, so there's no rendering, there's no dynamics, none of the like film features. You can render the viewport. So for example, you can render the viewport out as a play blast, so you can do sprites. So that's one thing we didn't get to cover today, but yeah, you can do, that's a 2D, you can do 2D, you can use 3D assets to create 2D sprite sheets using the DX level. So if you use like the shader editor, you can create some amazing materials, and you can still render that out as sprite sheets. Yep. But there's no mental array in it, that kind of thing. Yeah, because we wanted to make sure to keep the price as low as possible, right from from $3,600 down to $50 a month. It was a big jump. All right, I think that's all the time we have today. Thank you very much for checking out Maya LT. Take it easy.